Okay, we're going to apply the same sort of rules as earlier to our integration. So we are integrating now. You can see this doesn't have a bracket. Whenever it's not just an x and there's, please put a bracket around it, okay? They will do it to try and catch you out. If it's not an x, get a bracket around it, not just like a single x by itself. Right, we're integrating. We integrate, we go up the way. So sine, again, it's on your formula sheet. It's written like so. So sine goes to -1 over a, and again, it's the a is coming from if you differentiate what's inside the bracket, and then it's written like that with the cos. But if you remember this, I think it's much easier. So integrate, we go up the way. So actually, we're going to negative cos. So negative cos of 4x, look inside the bracket. We're dividing by it though, because it's integration, plus c. Okay, so we're differentiating that, we get that. So integration, divide by what's inside the bracket, the derivative of it. Right, again, there's no brackets there, so we're going to add them in. Cos, up the way, goes to sine. Look inside the bracket, differentiate it, we get 2, so we divide by 2. Cos, integrate, up the way, negative sine, negative cos. So I've got my plus c added. Divide by, what do you get, right? That, watch over here, 1 disappears, becomes -2 plus c. It's higher maths, never leave 2 negatives. Okay, so use your SC negative S negative C if you would like, or think about your formula sheet, whatever way suits you. The key is, again, if there's not a bracket, it's not a single x, bring that bracket in. And apply your rule, so sine goes to cos, or sine goes to negative cos, and so on, and then you differentiate what's inside the bracket, and we divide by it because it is integration. Right, part D. So evaluate between 0 and 2 pi, sine of a half x. Right, sine goes up, negative cos. So negative cos of a half x, divide by a half. Okay, now remember what happens when we're dividing by a fraction? The denominator comes up, so it's going to be -2 over 1, so I'm just going to get rid of the 1. Okay, we're going to sub that in. Brackets everywhere. And that's obviously going to give me 0. Okay, so -2 cos of pi minus -2 cos of 0. Right, cos of 0, remember, we need to think about, is that 0? Think about your graph. So pi is there, is -1. Cos of 0 is 1. So -2 times -1 is 2 minus -2, which gives us an answer of 4. So please take care with any sort of trig function when you're subbing in numbers. Check, it obviously doesn't always give you 0. Right, part E. Write cos squared x in terms of 2x, and hence find the integral of that. So what do we know with relates cos 2x and 2x? Well, you know your formula sheet. Your formula sheet says that cos 2x is 2 cos squared x minus 1. Now we want to figure out what cos squared x is, so I'm going to take the 1 over. I'm going to spin it round. And to get cos squared x, we're dividing that whole thing by 2. So you could write it as a half. Everything divided by 2, basically. You could write it as a half of the full thing. But basically we're dividing both of those by 2. So first one divided by 2 is a half of it, and 1 divided by 2 is a half. Then it says hence find that. So why is it asked us to do this? Because that is your cos 2x, cos squared x, and we know it's actually the same as this. So we're going to have 4 times a half cos 2x plus a half. Okay, 4 times a half, we're going to do that is 2. So this is in fact what we're integrating. Now we can see an x, it is not a single x, it is a 2x, so let's whack a bracket around that. Okay, so 2 cos integrates up the way goes to sine. Look inside the bracket, you get 2x, so we divide by 2. Integrate 2 goes to 2x, chuck your plus c on there. Cancel those 2's down. And that is our answer. Okay, now on your formula sheet, this is what it looks like. Okay, so f of x, sine ax will go to a cos ax. We need to differentiate it. And then the same with the cos one you can see. And that is what your integral looks like, again, on your formula sheet.